Today we see the passive elements and voltage equation. Here is the active elements and passive elements list. The active elements are the elements which are producing the power or switching the power, and the passive elements which are absorbing the power from the active elements. The basic elements are resistor, inductor and capacitor. The resistor, inductor and capacitor. Yes, the passive elements resistor, inductor and capacitor, which opposes the active elements, and it is also called as a sink or a load. The resistor, which opposes the flow of electron, is a pictorial representation of an resistor which opposes the current only, doesn't bother about the voltage. And the inductor, which opposes the change in current or flux. Here is some of the inductors that are normally used in our circuits. For example, FM radio, then oscillator circuits, then switching frequency circuits. And capacitor, which opposes the change in voltage. It allows the voltage, but it doesn't allow the change in voltage. And the passive elements are resistor, inductor, capacitor, and which opposes, resistor opposes the flow of current, inductor opposes the change in current, capacitor opposes the change in voltage. And the equation in voltage form for a resistor, which is R into I, that is IR is the Ohm's law, V directly proportional to IR. For a pure resistor, it is the Ohm's law equation I into R. And for the inductor, which is the change in current, L into di by dt. Di by dt is the rate of change of current, that is the change in current. It opposes the change in current. And similarly for the capacitor, it opposes the change in voltage, so C into dV by dt. Right. Let us assume an example with a circuit. A voltage is connected to a RLC circuit in series. So the current is same for all the passive elements. Then according to Kirchhoff voltage law, the sum of voltage rise V, which is equal to the sum of voltage drop across each element in the circuit, which is VR, the voltage across a resistor, and the voltage across inductor, and voltage across the capacitor. And we are equating to this equation V, which is equal to, for voltage across a resistor, V, which is equal to I into R, that is R into I of t, plus L into di by dt. For instead of VC, voltage across capacitor, which is C into dV by dt, we directly use this equation. But in this equation, we write in a voltage manner, that is voltage form. But this is in current form, V by I, V by R, which is the current form. So we have to replace this equation. Instead of C, we have to write the 1 by C. It's a reciprocal of voltage and current. And instead of differentiation, we have to write the integration. And instead of V, we have to write I dt. So 1 by C integration of I dt. Thank you.